Hello dear student friend, welcome for the lecture Non-Ferrous Alloys of our subject Engineering Materials and Metallurgy. Now in this non-ferrous alloys unit, we are going to discuss about different types of non-ferrous metals, their properties and applications. So what exactly the content of this unit is? The introduction to non-ferrous metals, types of non-ferrous metals. Popular non-ferrous metals are aluminum and their alloys, copper and their alloys, and some other non-ferrous metals are also there. We are going to discuss the properties of all these non-ferrous metals and their applications. So let us start with the non-ferrous metals introduction. Now non-ferrous metals are those metals which do not contain iron as a base metal. That means if you make iron, if you consider a iron as a base metal, that group of metal is called as ferrous metals, and without iron, the group of metal is called as non-ferrous metals. Now most commonly non-ferrous metals are aluminium, copper, lead, zinc, nickel, titanium, cobalt, chromium, and some of the precious metals are also come under this category. These are gold, silver and platinum. Now these non-ferrous metals are having some unique properties, and because of these unique properties they are used for different applications where our ferrous metals cannot be used. Now first attractive property is attractive color and the low density or low weight. For example, aluminium, then high thermal and electrical conductivity. For example, copper. Now non-magnetic property or resistance to corrosion is very high. For example, zinc, and these all non-ferrous metals are easy to fabricate. That means we can machine, we can cast, we can weld, we can forge, rod all these non-ferrous metals very easily with less amount of energy. Now this non-ferrous metal possess low strain to high temperature at high temperature, and they suffer from hot shortness, as well as they have more shrinkage than the ferrous metals. But having these limitations, still they are used for industrial applications. So let us start with different non-ferrous metals. The first non-ferrous metal is a copper. Now copper is, we know that it is a corrosion resistant metal having a reddish brown color. Now some common properties of this copper are high thermal conductivity, and due to which it is used for heat exchangers and heating vessels as well as appliances. Now copper has high electrical conductivity, and due to that it is used for electrical conductors in various shapes and forms. It has good resistance to corrosion. That's why it is used for protecting the as a protective coating on steel prior to nickel and chromium. Now it has high ductility. That's why it can be easily cold worked, folded, spun, but copper requires annealing after cold working as it loses its ductility after cold working. Now there are some common copper alloys having best conductivity for heat and electricity and with good corrosion resistance. These copper alloys include brasses and bronze. So let us see about this brass. All brasses are basically binary alloy of copper and zinc, as much as 50%. Brass has greater strength than the copper but has lower thermal conductivity as well as electrical conductivity. Brasses possess good corrosion resistance and easily solder. Tensile strength and the ductility of brass increases with increasing zinc content up to 30%. Various classes of brass such as cartridge brass, Mann's metal, leaded brass, admiralty brass, naval brass, they are widely used for special applications. Brasses are used in hydraulic fittings, pump linings, utensils, bearings and bushings. Now, common commercial types of brasses are named as number 1 alpha brass, which contains 36% zinc and remaining copper. Alpha beta brass contains more than 36 to 45% zinc and copper. Normally alpha beta brass is used for hot working purpose. Beta phase is less ductile as compared to alpha phase, but it is harder and stronger. So hot working process is used to make useful product from this alpha beta brass. Second category is a bronze. It is an alloy of copper and tin and usually termed as a bronze. Useful range of composition is 75 to 95% copper and remaining is a tin. In general, it possesses superior mechanical properties and good corrosion resistance. Now, the alloy can be easily used for cold work purpose, that is to make wires, rods and sheets. The bronze having increased tin content, the strength and corrosion resistance of this bronze increases. There are popular types of bronzes such as phosphor bronze. It contains phosphorus, that's why its name is phosphor bronze. It possesses good wearing quality and high elasticity. This phosphor bronze is resistant to salt water corrosion. It is used for the production of gears, nuts, machine components such as lead screws, springs, pump parts, linings, etc. Second bronze type is a gunmetal. It contains 2% zinc, 10% tin and 88% copper. Now the presence of zinc improves the fluidity so that it can take any shape of a mold during a casting. The bronze is used for mirroring bushes, glands, pump valves, boiler fittings, etc. Then another type of bronze are silicon bronze. Composition is 3% silicon, 1% manganese and rest is copper. This silicon bronze is good corrosion resistance and having high strength and toughness. It is widely used for boilers, tanks, stoves where high strength as well as corrosion resistance is required. Then bell metal. It contains 20 to 21% tin and rest is a copper. Now it is hard and resistance on to a surface wear. It can be readily cast. It is generally utilized for the manufacturing of belts, gongs and utensils. Now next bronze is a manganese bronze. It contains 55 to 60% copper, 40% zinc and very low, that is 3.5% manganese. This alloy is having high resistance to corrosion. It is stronger and harder than phosphor bronze. It is utilized for the production of bushes, then plungers, pumps, rods, etc. And the popular product, that is whirl gear, is made from this manganese bronze. Then next is a Mons metal. It contains 60% copper and 40% zinc. Sometimes it is named as 60-40% bronze. Small quantity of lead is also added. This is a stronger, harder and more ductile than all normal brasses. While hot work between 700 to 750, it responds excellently for process but does not respond to cold working process. Next non-ferrous metal is aluminium. We know that aluminium is white metal which is produced from alumina, that is Al2O3. In pure state, aluminium is soft and weak. Addition of copper, manganese, silicon, magnesium makes alloy more stronger and hard. It is also having good corrosion resistance, low weight and non-toxic. Now, like a copper, aluminium is having good corrosion resistance, good conductor of heat and electricity. it possesses high ductility, then lightweight so that it is used in aircraft industry. It requires annealing after cold work since it becomes harder after cold working. Due to its ductility and malleability, aluminum has replaced copper in electrical transmissions and appliances to some extent. It is used in manufacturing of household utensils including pressure cooker. Now these some of the popular copper aluminum alloys are duralumin. It contains 4% copper, 0.5% manganese, 0.5% magnesium and remaining aluminum. It has high strength as compared to mild steel and low specific gravity. Now duralumin improves corrosion resistance. A thin film of aluminum is rolled on the duralumin sheet known as aclad, and this aclad is used in the aircraft industry. Due to lightweight and high strength, this duralumin is also used in automobile industry. Then Y alloy contains 93% aluminum, 2% copper, 1% nickel and manganese. Then it has better strength at elevated temperature than duralumin. Therefore, it is much used in aircraft cylinders, cylinder heads and pistons. Then magnesium, 2% to 10% magnesium and remaining aluminum. Due to lightweight, good mechanical characteristics, it is used in aircraft and automobile components. Then hindalium, it is an alloy of aluminum and manganese with a small quantity of chromium. It is manufactured as rolled product in 16 gauge, mainly used in the manufacture of anodized utensils. Then next non-ferrous metal is nickel. Now about at least 85% of all nickel production is obtainable from sulfide ores. Now the properties of nickel are: pure nickel is tough, silver color metal, harder than copper, having some but less ductility, but about same weight. It is plated on steel to provide corrosion resistance on surface. Widely used as an alloying element with steel. Higher productions are advantageously added in the production of steel such as monel and conails. This nickel possesses good resistance to both acidic and alkalis regarding corrosion, so widely utilized in food processing equipments. Next non-ferrous metal of nickel alloy are German silver. Composition is 60% copper, 30% nickel and 10% zinc. It displays silvery appearance and it is very ductile and malleable. It is used for electrical contacts, castings of high quality valves, tabs consumed in jewelry. Then it is also used in the production of electrical wires. Then monel metals. Now these monel metals contains 68% nickel, 30% copper, 1% iron and remaining small amount of manganese. Its corrosion resistance possesses good mechanical properties, maintain them at elevated temperature also. Nichrome, it is an alloy of nickel and chromium, widely used for heat resistant wires and electrical appliances. Then inconel is the alloy of nickel, chromium, iron, molybdenum and titanium. It is a small portion of carbon. Uses high temperature alloy. Inconel does not respond to heat treatment. So these are the non-ferrous alloy. Next is the bearing material, which is copper, popularly used for manufacturing of bearings, and a common bearing properties bearing material are expected to have are the good wear resistance, then Coefficient of friction of bearing material should be as low